Hey guys, welcome to day 4 of week 4 of physics. So today is actually going to be a test review. So you have a test coming up on Tuesday, April 21st. It's going to happen at 1:30 p.m. So what we're going to do is you're going to take it on RunWeb, but you have to actually call in for a Zoom meeting. So that way I can proctor the exam. You will have from 1:30 to 2:30 on that Tuesday. So please be sure you show up. I have the invitation all set for you, but I'll also send out an announcement on RunWeb the day of the test, so that way you're not hunting for the link or anything like that. The reason why I'm doing it that way is just to hold everybody accountable. I know that it's really difficult to do school online, and it's really difficult to do testing online. So one of the ways that we can still take tests with integrity is by having me proctor the exam via Zoom. So I know I don't have to worry about that with any of y'all, but please be sure that you check in with Zoom, because if you just go on RunWeb and take the test and you don't show up to the Zoom call, I gotta count the test as a 0 because you didn't follow the instructions and there was no accountability there. So please be sure you do that, and yeah, I don't think we'll have any issues with that. If you have any questions or concerns, please let me know. I put my number also in the announcement, so that way if you need something immediately and you can't get a hold of me via email or RunWeb, you can call or text me at 843-834-3333. And that's not a joke, that's actually my number. I just want to be sure everybody has what they need. So if something happens or you have a question or whatever, please just let me know. But I plan to see all of y'all on Tuesday, April 21st at 1:30 p.m. So let's go ahead and do this test review on work and energy. So you should have all of this in your notes already. So if you need to go back and look at something, please do that. Otherwise, I'm just going to kind of go through my PowerPoint here. It's not connected to the video. I'm having some technical difficulties, but really you don't need it. You should have everything written down. So if there's any questions about that, please let me know. If you did not take notes, if it was not in my PowerPoint presentation that I have given you the past couple of weeks, it will not be on your test. So if there was a slide on it and I've talked about it, or it was in the Khan Academy video that I gave you guys this past week, which there was only 2 of them, if it's not in either of those things, then it will not be on your test. So I want everybody to be comfortable with that and not freak out about anything. Okay, so I'm just going to kind of do a real quick review. So if we were just to describe work, what would it look like mathematically? So I'm going to pause for a second to kind of let you think before just giving you answers, so that way it kind of jogs your brain. But it will feel awkward and like Blue's Clues, but I just think it's a good way to remember stuff. So you will have, I'm sorry, I'm like all over the place, but for this test, it's going to look a lot like my other tests, where you will have content, actual questions about the content you're being tested on, like multiple choice and stuff. And then there will also be math problems, obviously, that will be weighed a little bit heavier than the content questions. I'm sorry, my baby's sleeping right now, and so I keep checking in on her. All right, so if I were to describe work mathematically, how would I write it? It would be work equals what? Force times distance, right? So anytime we are pushing or exerting external force on an object, we are or over a course of a distance or displacement, that is work that is happening. So force times distance is going to be equal to work. So work can be a positive, a negative, or a 0 quantity. Okay? What is the unit that we use for both energy and work? It's going to be joules. Okay? So with work equals force times distance, you are going to need to know that equation. You need to know all the equations that I say today. So work is the first one. If I were to give you a problem that says, what is the work required if we pushed a rock using 10 newtons of force for a distance of 7 meters? We know that work equals force times distance. So all we would have to do is plug in our numbers. So 10 newtons of force times 7 meters of distance. So that's going to equal 70 joules of work, right? So you need to be able to do that same kind of problem if I were to give you the joule or the work quantity in joules is equal to, maybe I give you distance, but I don't give you the force required. All you would have to do is flip the numbers around, okay? So you need to be able to do it backwards and forwards. All right, so energy is going to be the ability to do work, okay? We have two types of energy. What's the two types of energy that we've talked about? Potential and kinetic. Okay, let's talk about kinetic energy first. So kinetic energy is going to be energy associated with what? Is it going to be associated with staying still or with movement? With movement, right? Okay, it's also going to be measured in joules. And it's going to be the energy of an object because of its motion. So, if we want to accelerate an object, then we must apply a force. And applying a force requires us to do work. So, after the work has been done, energy is being transferred onto that object. And that object's going to be moving at a new constant speed, right? So, velocity is going to come into play with kinetic energy. So, the energy transferred to that object is going to be known as kinetic energy. And it's going to depend on two things: the mass of the object and the speed of the object. Okay, so our formula, here we go. Nope, I thought I got it to work. Our formula, that is the slideshow though. Let's see, guys, maybe I got it. So our formula for kinetic energy is going to be, there it is going to be, this is the second formula you need to know. K equals 1/2 times mass times your velocity squared. So something to note is that kinetic energy has to be a positive quantity. So that makes sense, right? If it is the quantity of motion, you can't take away motion, right? It's not going to be negative motion. You can't have negative kinetic energy. It's only going to be positive. It also can equal 0. Okay? All right, let's see. All right, you guys have all that. All right, so make sure, again, that you're able to do problems like that different kinds of ways. So if I were to give you the kinetic energy and the mass of an object, you would need to be able to tell me the speed of that object. So it's kinetic energy equals 1/2 times mass times velocity squared. And if you need to go back and look at the practice problems and the homework that we've already done with these, please do so, because that's exactly how they're going to look on the test. All right, so kinetic energy is going to depend on the velocity of the object. It's also going to depend on the mass, like we've already talked about. Okay, so potential energy. Oh, one more thing about kinetic energy. And the reason why I'm not showing you these slides is because those are not the correct slides. I edit them, and for some reason the edited version of these slides are not going onto the video, and I'm sorry about that. So only certain slides actually made it, and I don't understand how that works. But Anywho, so one more thing about kinetic energy is that direction is not going to matter. So remember, that means that it is a scalar quantity. So, continuing, potential energy is going to be energy due to what? An object's position. Okay? So, it is also measured with the unit of joules. And the best way to think about this is like with a rubber band. When you pull it back, there's potential energy. It's due to the object's position. And then when you release that, so with your catapults, when you release that, that potential energy is going to be converted into kinetic energy. You need to know the gravitational potential energy formula, which is, remember, mass times gravitational acceleration times height. So m times g times h. I am going to, this is what I will do for y'all. I'm thinking out loud on the spot. I'm sorry. I will be sure to attach a document that has a list of the formulas you need to know. So that way you don't have to go hunting for all of the different stuff. All right. So remember, we talked about conservative forces. So it's conservative forces is going to be work done by force that only depends on the initial and the final position of the object. So the path taken by the mass is not going to matter. So remember, we talked about gravitational force. It doesn't matter the direction. Gravitational force is gravitational force. Okay? So two examples. You need to know two examples of a conservative force, and that's going to be gravitational and spring forces. And then you need to know two examples of non-conservative forces, which would be kinetic frictional force and air resistance. Okay, so elastic potential energy is the next thing. So this is going to be energy stored as a result of applying a force to deform an elastic object. So think about your catapult. So when I used the spoon as a catapult, I was actually deforming the object. So I had this potential energy stored, and then as I released it, that energy was actually converted into kinetic energy. Okay, so I gave some examples of elastic potential energy. So be sure that you're familiar with some examples. You can come up with your own if you want, but some that I gave was like an archer's stretched bow, a bent diving board, a twisted rubber band, all that good stuff. So that leads us into talking about springs. So remember, springs in physics, so they can be like the little springs that you see, typical springs. But when we say springs in physics, we're talking about an object that can be deformed by a force and then returned to its original shape once the force is removed. So think about a diving board. When somebody's applying force and stepping on it, it's actually deforming the diving board, and when that person jumps off and removes that force, the diving board is actually going to return back to its original shape. So that's an example of a spring. So we talked about Hooke's law and elastic potential energy in the two Khan Academy videos that I sent you guys. They are absolutely fabulous, I think, at describing springs and Hooke's law as far as mathematically. So be sure that you have watched those, because I think they are super helpful. He has drawings and everything. It's really, really easy. But if you have any questions about those, please let me know. Otherwise, I'm going to just put a document in here that has a list of the formulas you need to be familiar with. And I think y'all are going to do great on your test on Tuesday. And if you have any questions, please, please, please reach out to me and let me know. All right. I'll see y'all later.